Now we discuss problem number 9. It says write the Nernst equation and calculate the EMF of the following cell at 298 K. The Cu to Cu2 plus 0.130 m, Ag plus 1 times 10 to the minus 4 m to Ag. And the value of E naughts are given. E naught Cu2 plus to Cu gives 0.34 volt and E naught Ag plus to Ag gives 0.80 volt. Now we need to see, okay, so from the cell actually, so in anode oxidation takes place, so Cu goes to Cu2 plus. So the electrode reactions and cell reactions are the electrode reactions and the overall cell reaction can be represented as so at anode oxidation takes place. So at anode Cu solid goes to Cu2 plus with concentration of 0.130 molar, okay, and at anode and 2 electrons at anode, and at anode this is the cell reaction, and at cathode Ag plus E gives Ag. Right. So if we multiply this equation by 2, we get 2 Ag plus 2 electron gives 2 Ag solid. So the overall reaction, the overall cell reaction we can write as Cu solid plus 2 Ag plus aqueous produces Cu2 plus aqueous plus 2 Ag solid. Right. Now according to Nernst equation at 298 K, at 298 K temperature, E cell is E naught cell minus RT by F. So we can write 0 at 298 K temperature, we can write 0.059 by 2 electrons are involved here. So 0.059 by 2 log. Now concentration of product, so concentration of Cu2 plus by concentration of Ag plus raised to the 2. Since concentration of Ag and Cu are 1 solid, both are solid, so we are omitting that. Now what is E naught cell? E naught cell is we can write as cathode minus anode, so we get E naught cell is 0.8 minus 0. Cathode minus anode, so 0.8 minus 0.34, that is your E naught cell, and then this is 0.059 by 2 log. Concentration of Cu2 plus is given is 0.130 and concentration of Ag plus is 1 times 10 to the minus 4 raised to the 2. If we calculate this one, we get this is minus 0.46 and this value will give you 0.21, so we get 0.25 volt. So this is the EMF of the cell, the EMF of the cell, that is E cell. So EMF of the cell is 0.25 volt. Next, we discuss problem number 10. It says the standard reduction potential for E naught or E naught Cu2 to Cu is 0.34 volt. Calculate the reduction potential at pH 14 for the above couple. So, Ksp of CuOH2 is given 1 times 10 to the minus 19. Okay. So, for pH 14, so for pH equals to 14, we write minus log concentration of H plus is 14. So, we get concentration of H plus is 10 to the minus 14. Okay. Again, at 298 K temperature, Kw is concentration of H plus times concentration of OH minus equals to 1 times 10 to the minus 14. So, we can calculate concentration of OH minus is 1 times 10 to the minus 14 by 10 to the minus 14. So, gives 1. So, concentration of OH minus is 1 here. Okay. Why we need to calculate concentration of OH minus? Because we need to calculate the concentration of Cu2 plus from the Ksp of CuOH whole 2, because we know that now concentration of OH minus is 1. So, from there, from the Ksp of CuOH whole 2, we can calculate the concentration of Cu2 plus. Okay. Again, CuOH whole 2 dissociates as Cu2 plus 2 OH minus, right. Okay. Now, Ksp, so the solubility product of CuOH whole 2, that is Ksp, you can write is concentration of Cu2 plus times concentration of OH minus raised to the 2, right. So, we can calculate concentration of Cu2 plus. Okay. So, is nothing but Ksp by concentration of OH minus raised to the 2. So, value of Ksp we know 1 times 10 to the minus 19 by 1 square. So, we get basically Cu2 plus concentration is 10 to the minus 19 or 1 times 10 to the minus 19. Okay, so, now we know the concentration of Cu2 plus. Okay. So, the cell reaction is Cu2 plus 2E gives Cu solid, right. So, E is E naught minus 0.059 by 2 at 298 K. At 298 K temperature, so we write E equals to E naught minus 0.059 by 2, then log concentration of Cu, concentration of Cu2 plus. Now, value of E naught we know is 0.34 volt minus 0.059 by 2, then log 1 by concentration of Cu2 plus is 1 times 10 to the minus 19. Okay. So, if we calculate this one, so we get E is 0.34 and the value of the other quantity is minus 0.56. So, E will be, minus 0.22. So, the reduction potential at, therefore, the reduction potential at pH 14 will be the reduction potential for Cu2 plus 2Cu at pH 14 will be minus 0.22 volt. Now, problem number 11 says two students use same stock solution of ZnSO4 and a solution of CuSO4. The EMF of one cell is 0.03 volt higher than the other. The concentration of CuSO4 in the cell with higher PMF is 0.5 m. Find the concentration of CuSO4 on the other cell. Use 2.303 times RT by F is 0.06. The two cells may be represented as or can be represented as Zn solid, Zn2 plus, concentration C, and Cu2 plus, and if we consider concentration C and we do not know the value to Cu, and the corresponding EMF is given, or we can consider this is E1 suppose, huh? And then another cell we consider is Zn is Zn2 plus, concentration is C, and then Cu2 plus, concentration of 0.5 molar here, then Cu, and then EMF we are considering E2. Let us consider. The CL reaction, the overall CL reaction for both the cells, the overall cell reaction for both the cells, both the above cells can be written as Zn is getting oxidized. So, Zns plus Cu2 plus gives Zn2 plus aqueous plus Cu solid, right. So, E cell, this is applicable for both the cells. Okay. So, E cells will be E naught cell minus 0.06 by 2 log concentration of C by concentration of Cu2 plus. This is for cell 1, this is for cell 1, and for the next cell we can write. So, this is we can consider E1, right, for EMF is considered E1. So, this is E2 for cell 2. So, E cell will be E naught cell minus 0.06 by 2 log again concentration of Zn2 plus is C, and concentration here is 0.5, right. So, this is equation 2. Now, if we subtract equation 1 from 2, so subtracting equation 1 from equation 2, we get, so on subtracting, we get E2 minus E1. Okay, so E2 minus E1, E naught cell will get cancelled. So we get 0.06 by 2, right, and then log C by concentration of Cu2 plus minus log C by 0.5. Okay, so the value is given, the cell, this EMF of one cell is 0.03 volt higher than the other. So difference is 0.03 volt. Okay, and this is also giving you 0.03. So log this minus this, so we get 0.5 by concentration of Cu2 plus. So 1 gives you log 0.5 by concentration of Cu2 plus. Is log 10 is log 0.5 by concentration of Cu2 plus. So we can calculate concentration of Cu2 plus. So basically this gives 10 is 0.5 by, so 1 is nothing but log 10. Okay, so we are substituting that actually here. So Cu2 plus, so concentration of Cu2 plus will be 0.5 by 10. So we get 0.05. Therefore, the concentration find the concentration of CuSO4 on the other cell. Therefore, the concentration of CuSO4, therefore the concentration of CuSO4 on the other cell is 0.05 molar. Next we discuss problem number 12. It says that EMF of the cells is given. Okay, Zn goes to Zn2 plus and Zn and cadmium 2 plus to C cadmium is 0.3305 volt at 298 K. Calculate the value of M1 given E naught values are given. So basically E cell is given and E naught values are given, reduction potential values are given for both the electrodes. So we need to calculate the concentration of cadmium 2 plus at cathode. Okay, so the cell reaction, okay, the half cell reaction rather. So at anode, so at anode oxidation takes place. So Zn goes to Zn solid goes to Zn2 plus aqueous plus 2 electron. At cathode, reduction takes place. So Cd 2 plus aqueous goes plus 2 electron gives Cd solid. The overall cell reaction so if we add them, we get the overall cell reaction is Zn solid plus Cd 2 plus aqueous gives Zn2 plus aqueous plus CdS, and N in this reaction is 2. Okay, 2 electrons are involved here. Okay, so we got the total or overall cell reaction. Okay, again the reduction potential or the standard reduction potential of the cell of the cell if we say this is E0 cell is E0 cathode, right, E0 cathode minus E0 anode. So, E0 cathode is nothing but E0 in cathode we get CD 2 plus 2 CD minus E0 anode is Zn 2 plus 2 Zn. Okay, so we get the value of E0 cell. So now we substitute the value of E0 cathode and anode. So this is minus 0.40 and this is your minus 0.76. Okay, so if we calculate, we get the value of E0 cell is 0.36 volt. This is the value of E0 cell. Now from Nernst equation, at 298 K, we can write 298 K temperature. We can write E cell is E0 cell minus 0.06 by 2 log concentration of Zn2 plus by concentration of CD 2 plus. Now value of E cell is given, right? Yeah, E of the cell is given 0.3305. E0 cell we calculated 0.36 minus this is 0.03 and log concentration of Zn2 plus is also given 0.1 and concentration of CD2 plus we need to calculate. So we get 0.03 log 0.1 by concentration of CD2 plus gives 0.36 minus 0.3305. Okay, so if we calculate this one, okay, so we get the concentration of CD2 plus we get 0.01 molar. Okay. Therefore, so concentration of CD2 plus is nothing but M1 is given, right. So we can further write this one is 0.36 minus 0.03 log 0.1 by M. So we can write this one also M. Okay, so therefore we can write this is also not M1. Okay, we can write M1. So we can calculate M1. Therefore, the concentration of CD2 plus that is your M1 is 0.01 molar. Move to problem number 13. It says a copper silver cell is set up. The copper ion concentration in it is 0.1 m. The concentration of silver ion is not known. The cell potential is also found to be 0.422 V. Determine the concentration of silver ion in the cell. So it is like very similar problem that we discussed just now. So E0 Ag plus and Ag given 0.8 volt and E0 Cu2 plus to Cu given is 0.34 volt. Now here the overall cell reaction can be written as here E0 value of Ag plus is higher than, okay, here the E0 value. So here the E naught value, standard reduction potential of Ag plus to Ag, because we need to find out the cathode and anode. Okay. So, for that we need to do it. Okay. So, here the standard reduction potential of Ag plus to Ag is higher than that of Cu2 plus to Cu. Therefore, at cathode, where reduction takes place, so standard reduction potential of Ag plus is higher than that of Cu2 plus to Cu. So, Ag plus will be readily reduced. Okay. So, at cathode Ag plus aqueous, so goes to Ag. Okay. So, Ag plus aqueous plus electron goes to Ag solid, and at anode oxidation takes place, right. So, at anode oxidation takes place. So, we get as Cu solid goes to Cu2 plus aqueous plus 2 electron. So, if we multiply this by 2 and add them, so the overall cell reaction, if we multiply 2 and then add, then electron number of electrons will get cancelled. So, the overall cell reaction will be Ag plus aqueous, 2 Ag plus aqueous plus Cus gives Ag solid plus Cu2 plus aqueous. Okay. The standard reduction potential of the cell, standard reduction potential of the cell we say this is E naught cell is E naught cathode minus E naught anode. So, E naught cell we can calculate now. So, E naught cathode is our Ag plus to Ag. So, this is 0.80 minus E naught anode. So, anode will be at 0.34. So, you get 0.46 volt. That this is our E naught cell. Again, from Nernst equation, at 298 K temperature, we can write so for the overall cell reaction N equals to 2 here. Okay. So, at 298 K, from Nernst equation at 298 K temperature, we write E cell is E naught cell minus 0.06 by 2 log concentration of Cu2 plus by concentration of Ag plus raised to the 2. Now, concentration of silver ion is not known. Okay. So, we need to calculate the concentration of silver ion, but concentration of copper ion is given. Okay. So, concentration of copper ion is is 0.10 mole. Okay. Again, and concentration of copper ion Cu2 plus is 0.10 m, but concentration of Ag plus we need to calculate. Okay, so, now we put the value of E cell is given 0.422 volt, and E naught cell we also calculated 0.46 volt. So, minus 0.03 and the log concentration is 0.1 by concentration of Ag plus raised to the 2. Okay, so we get 0.03 log concentration of 0.1 by concentration of Ag plus raised to the 2 is, so we are taking the whole thing this side, and this the other side we get 0.038. Okay, so if we calculate this one, we get concentration of Ag plus raised to the 2, okay, is 0.1 by 19.413. So concentration of Ag plus will be square root of 5 times 10 to the minus 3. So we get concentration of Ag plus is 0.07 m. So we got, okay, therefore the concentration of silver ion Ag plus is 0.07 m.